Disaster recovery, an overview. Disaster recovery (DR) is a strategic approach designed to help organizations recover from significant disruptions, ensuring business continuity and minimizing downtime. Disasters can range from natural events like floods, earthquakes, and fires to human-made incidents such as cyber attacks, hardware failures, or power outages. Disaster recovery involves a set of policies, tools, and procedures aimed at protecting an organization from the effects of these events and enabling the resumption of critical operations as quickly as possible. Key concepts in disaster recovery. 1. Business continuity, BC. Business continuity is the broader concept that encompasses disaster recovery. While DR focuses on IT and technology recovery, BC involves maintaining all essential functions of a business during and after a disaster. It ensures that critical business operations can continue with minimal interruption. Number 2, Recovery Point Objective, RPO. RPO defines the maximum acceptable amount of data loss measured in time. It answers the question, how much data can we afford to lose? For example, if an organization's RPO is 4 hours, it means they can afford to lose up to 4 hours of data. This helps in determining the frequency of backups. 3. Recovery Time Objective, RTO. And for RTO is the maximum acceptable amount of time to restore normal operations after a disaster. It answers the question, how quickly do we need to recover? For instance, if the RTO is 2 hours, the organization must restore its systems within that time to avoid significant impact. 4. Disaster Recovery Plan (RP). A disaster recovery plan is a documented process or set of procedures to recover and protect a business IT infrastructure in the event of a disaster. It includes detailed steps to follow, the roles and responsibilities of key personnel, and the resources required to execute the plan. 5. Data backup. Data backup involves copying and archiving data to ensure it can be restored in case of a disaster. Backups can be stored on-site, off-site, or in the cloud. There are several types of backups. Full backup, a complete copy of all data. Incremental backup, only the data that has changed since the last backup is copied. Differential backup, data that has changed since the last full backup is copied. 6. Replication. Replication involves copying data to another location in real time or at regular intervals. It ensures that a live copy of the data is available in a secondary location, which can be used immediately if the primary site fails. There are 2 types of replication. Synchronous replication. Data is copied simultaneously to the secondary site as it is written to the primary site, ensuring zero data loss. Asynchronous replication. Data is copied to the secondary site with a slight delay, allowing for potential data loss, but often at a lower cost. 7. Failover and failback. Failover is the process of switching to a backup system, server, or network in case of a failure in the primary system. This switch can be automatic or manual. Failback is the process of returning operations to the original system after the issue is resolved. 8. Hot site, warm site, and cold site. Hot site, a fully operational backup site with real-time data replication, allowing for immediate failover. Hot sites are expensive but offer minimal downtime. Warm site, a partially equipped backup site that requires some time to become fully operational. It's a middle ground solution in terms of cost and recovery time. Cold site, a backup site with the basic infrastructure but no active data replication. It takes the longest to become operational but is the least expensive. 9. Cloud-based disaster recovery. Cloud-based DR leverages cloud computing to back up data and applications in a secure offsite location. Cloud DR solutions are scalable and often more cost-effective than traditional DR methods. They allow organizations to recover data and systems more quickly and efficiently. 10. Disaster Recovery as a Service, DRaaS. DRaaS is a cloud-based service where a third-party provider hosts and manages the disaster recovery plan. In the event of a disaster, the provider takes over the organization's IT operations, ensuring minimal disruption and swift recovery. 11. Disaster Recovery Testing. DR testing is the process of validating the effectiveness of a DRP. Regular testing helps identify gaps and weaknesses in the plan, ensuring that the organization is prepared for an actual disaster. Types of tests include walkthrough test, reviewing the DRP with key personnel, simulation test, conducting a mock disaster to test the response, Full-scale test, a complete activation of the DRP in a controlled environment. 12. Risk assessment and impact analysis. Risk assessment involves identifying potential threats and vulnerabilities that could impact the organization. Impact analysis evaluates the potential effects of these risks on business operations, helping to prioritize recovery efforts and allocate resources effectively. 13. Redundancy. Redundancy involves duplicating critical components or functions of a system to increase reliability and availability. In DR, redundancy might mean having multiple servers, network paths, or data centers so that if one fails, others can take over without interruption. 14. Incident response. Incident response is the immediate reaction to a disaster event, focusing on mitigating the impact, containing the damage, and initiating recovery procedures. It often works in conjunction with the DRP, but is more focused on the initial handling of the disaster. 15. Service level agreements, SLAs. SLAs are contracts between a service provider and a customer that specify the expected level of service. In the context of DR, SLAs define the acceptable RPO and RTO, ensuring that the service provider meets the organization's recovery needs. 16. Business Impact Analysis, BIA. BIA is a critical component of a DRP. It involves identifying critical business functions and the resources required to support them. The BIA helps prioritize recovery efforts and ensures that the most crucial functions are restored first. 17. Compliance and regulatory requirements. Many industries have specific compliance and regulatory requirements related to DR. These regulations often dictate how data should be protected, the minimum RPO and RTO, and how frequently DR plans should be tested. Compliance ensures that an organization meets legal obligations and avoids penalties. 18. Downtime costs. Downtime costs refer to the financial losses incurred when an organization's systems are down. This can include lost revenue, reduced productivity, and damage to the organization's reputation. Understanding these costs helps justify investment in robust DR solutions. Real-life use cases of disaster recovery. 1. Natural disasters. Example, a large enterprise with a data center in a hurricane-prone area implemented a DRP that included real-time data replication to an out-of-state data center. When a hurricane struck, they were able to switch to the backup site with minimal downtime, ensuring business continuity. 2. Cyber attacks. Example, a financial institution suffered a ransomware attack that encrypted critical customer data. Thanks to their DRP, which included regular backups and a tested incident response plan, they restored the affected systems and data from backups without paying the ransom. 3. Hardware failures. Example, a manufacturing company experienced a server failure that brought down their production management system. With a warm site in place, they were able to switch operations to the backup site within hours, minimizing production downtime. 4. Human error. Example, an employee accidentally deleted important files from the company's main server. Because of their regular incremental backups, the IT team was able to recover the lost files within minutes, avoiding significant disruption. Conclusion. Disaster recovery is an essential aspect of modern business operations, ensuring that organizations can recover from disruptions quickly and effectively. By understanding and implementing the key concepts of DR, such as RPO, RTO, data backup, and replication, businesses can protect themselves from various threats, minimize downtime, and maintain continuity in the face of adversity. Regular testing and updates to the DRP are crucial to ensure preparedness and resilience in an ever-changing threat landscape.